Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's algebra class. Today we're going to talk about chapter 2. We're going to start talking about inequalities. Very easy stuff, especially section 1, where we're just graphing and writing inequalities. But at the same time, it's probably the most important section of the chapter. Because if you don't know the vocabulary, you don't know the nuances of what goes on here, it's going to be much more difficult as we continue. So let's really focus and make sure we understand these definitions. First of all, my friends, when we're talking about an equation, we just finished talking about equations. Equations are expressions that use an equal sign. So if you have an equals attached to an expression, that's called an equation. Okay? It comes from equate, the root equate, to be equal. Now, inequalities, okay, they use what are called inequality signs or inequality symbols. Here, from left to right, we have less than, greater than, less than or equal to, or greater than or equal to. Let's describe these as easy as they are. Sometimes my students make careless errors. Why? Because they don't know the basics. So I want to make sure you really understand this. Okay. When we're talking about less than, guys, this is the symbol for less than, okay? It's the symbol for less than if I'm reading from left to right. It's the symbol for less than if I'm reading from left to right because the right side is being eaten by the alligator, right? I know that's like kindergarten stuff, but that really helps. Okay, the larger side will be eaten by the gator. So I have A, this inequality sign B. That's read as A is less than B. That means that A is less than B. It's smaller than B. Done. Greater than. We're reading from left to right. A is greater than B. That means the value of A is larger than the value of B. Less than or equal to. Notice that for the less than or equal to, you have that little equal to sign as well. So what this reads is A is less than or equal to B. That means that A can be less than B, or it could be equal to B. Okay? No, it cannot be more than B. No. Greater than or equal to. Notice again, you have the little equal sign. So when I have A is greater than or equal to B, that means that A is larger than B, or it could be equal to B. Very good. And then if I have an equal sign with a little slash through it, that basically means not equal to. Pretty simple. Now, when we're talking about the solutions, and notice how I say plural, solutions of an inequality, okay? The solutions of an inequality are the values that make the given inequality true. So when you have a solution, solutions of inequalities are basically infinite, pretty much. For example, if I have x is greater than 5, my friends, just give me some examples of what the solution would be. Okay, 12, 6, I heard someone say. 12.3, very good. 1900, excellent. Okay, 599, yes. 541, yes. Anything larger than 5. What about 5 itself? Can 5 be a solution? No, sir. Good job. 5.1, yes. 5.000001, yes. But it cannot be 5. It must be larger than 5. What if I said to you x is less than 3? What are some possible solutions here? 2, 1, 0, negative 1, negative 2.99, 2.99. Yes, excellent. Excellent. Does that make sense, guys? Okay. So you can have an infinite number of solutions. Yes, sir. Not equal to would be more like 7 is not equal to 6. You could also say 7 is greater than 6 or 6 is less than 7. That's fine. But I just want to show you that the not equal, what that means. I don't want you to see that and not understand it. Thank you, son. Yes, sir. Would they ever give you inequalities with fractions? Of course. 100% of the time. Absolutely. All right. Now, when dealing with word problems, guys, you got to remember two very important phrases. It's the at most and the at least. This is what really, really messes my students up most of the time in the word problems. They don't remember what it means. So let's try to think of this. Think opposites. When you hear at most, wouldn't you think greater than or equal to? Well, logically, at most, you're thinking more. Reverse it. It's less than. At most is less than or equal to. I like to always give these examples with age, okay? Mr. Morrow is at most 40 years old. What does that mean? That means that I'm 40 or less. So if I say Morrow is at most 40, the inequality would be M for Morrow is less than or equal to 40. Does that make sense? Okay. Now, at least is reversed, is greater than or equal to. Mr. Morrow is at least 40, means that Mr. Morrow is 40 or more. So if I told you write the inequality, Mr. Morrow is at least 40, it means that M for Morrow is greater than or equal to 40. Does that at most and at least make sense, guys? Okay, awesome. Come again, sir? Well, if I said Morrow is 40, what does is mean? So M equals 40. Okay? Thank you very much. But is, we're talking about an equation. When I say is at least, we're talking about greater than or equal to. Is at most less than or equal to. Thank you, sir. All right. Now, graphing inequalities. When graphing inequalities, remember, please make sure that your PDF notes are correct. I had to switch these. I made a mistake when I posted your PDFs. Please make the change. All right, bless you. When dealing with less than or greater than, just straight up less than or straight up greater than, all right, you're going to use an open circle. Don't do a square like I just did. I'm just showing you. It's an open circle. So what happens here, okay, less than or greater than, use an open circle. Now, if I'm going to use less than or equal to, or greater than or equal to, I'm going to use a solid circle. Now, the question that most people would never ask, but I'm going to hopefully answer for you is, why, Mr. Morrow? Why? Let's think about this. If I tell you that x is greater than 6, that means that every single value less than 6 is acceptable, correct? So everything to the left of 6 is acceptable, right? But 6 itself is not included, right? So I put an open circle to show, hey, reader, this is where I'm starting at the 6, okay? But I'm going to go to the left of it because all of those answers are valid. However, since I have an open circle, I am not included in the solution, so therefore it must be an open circle. And I did this wrong. This should have been x is less than 6, sorry. Okay? No. Okay, they just told me this. Go with the arrow. Wrong. Really? Go with the arrow? No. Do not go with the arrow. Please do not. Always read from the variable. Not the arrow, but from the variable. Now, what if I told you x is less than or equal to 6? Well, in that case, isn't 6 part of the solution? So I can include it with a solid circle, and then I shade to the left. Does that help you guys understand why it's open circle for greater than or less than, and closed circle for less than or equal to or greater than or equal to? Awesome. Yes, sir. Okay, that doesn't make sense. I was asked, you go the way the x is supposed to be. I don't know what that means. You graph it, you read it from the variable. So I don't know what you're trying to say. I don't understand, sir. I'm sorry. But let me give you some examples. X is less than 5. Where's our starting point? 5. Open circle or closed? Open. X is less than 5. So it's going to be to the left. Okay? Now, what if I wrote it like this, though? According to the arrows theory, which way would I have gone? To the right, which would have been wrong. Always read from the variable. X is less than 5. Less than 5. So please do not do the arrow method. That works when it's only in one format. It does not work always. From now on, we're in algebra, you read from the variable. How about this guy? Number 2. X is greater than or equal to negative 2. Okay, closed circle on what? Good job. And then x is greater than or equal to negative 2. I'm going to go to the right. Remember, I'm not going by the arrow. I'm going by reading from the variable. X is less than negative 4. Where's my negative 4? Open or closed? Less than. Am I going to go to the left or to the right? X is less than negative 4. Very good. Please shade it in, guys. I know that some teachers have taught you to do it above the graph. Do not do that. Some teachers have taught you to do a little arrow. Do not do that. Please shade everything on the graph, please, and thank you. X is greater than 3. Okay, 3, open circle or closed? Open, and I move to the right. Very good. Excellent. Now, I'm going to write some inequalities for you. You guys write them down, and then I want you to give me the actual inequality. Okay, I'm going to write the graph. It's on the negative 2, open circle, going to the right. For number 2, it's closed circle on the negative 1, going to the left. On number 3, we're going to do an open circle on the 0, going to the right. And for number 4, we're going to do a closed circle on negative 3, going to the left. So, first go ahead and take a second to write those down. And then you guys are going to tell me what the inequalities are. Okay, I'll give you a minute to do that. Okay, let's see what we got here. Number 1, open circle on the negative 2, shaded to the right. Yes, sir. X is less than negative 2, you mean? Thank you very much. Good job. X is less than negative 2. Good. Number 2, sir. And actually, wait. This is wrong. Hold on. What's wrong with me? This is x is greater than negative 2 because it's going to the right. Sorry, I should have paid attention. Number 2, x is less than or equal to negative 1. Number 3, what do we got here? Yes, sir. Okay, X is greater than 0. It's open circle and it's going to the right. So that means it's greater than 0. And last but not least, yes sir, X is less than or equal to -3. Very good. Does that make sense, guys? Awesome blossom. We're done. Hope you enjoyed it. I hope you learned a lot. Thank you very much. And I'll see you tomorrow.